Next type, reciprocal graphs. And we've seen some of these in a couple of different contexts. Back when we did trig, and we drew the sec and cosec and cotan graphs and what have you. But we can find the reciprocal of any graph. Things to look for. Well, if the original function is 0, then when I turn it upside down, I'm going to have 1 divided by 0, which is undefined. So quite possibly we're going to end up with a vertical asymptote at that point. So here's random graph. Wow. So there we go. Each of those x-intercepts, I'm expecting a vertical asymptote. Might end up being a point discontinuity. We'll just see what the graph ends up doing. But it's most likely going to be a vertical asymptote. Okay? Now, the reverse is going to happen. When we have an asymptote, a vertical asymptote, which of course is when the function is approaching infinity or minus infinity, then if I turn that upside down, I must go back to 0. Okay? So it will approach 0. So the asymptotes will become x-intercepts, but not really. Okay? I'll show you what I mean. So in our random graph here, I have a vertical asymptote. So on the reciprocal, it will become an x-intercept, but not really. I've circled it because remember, if it's not in the domain of the original function, it can't be in the domain of the new function. Okay. What else have I just plotted in there? When you turn the number 1 upside down, you get... So we know that wherever the y value is equal to 1, those points will remain. So on my blue random curve there, I've just marked in 1. Same thing's true if you turn negative 1 upside down. So let's plot those ones in. Well, that's meant to be negative 1 over there, pretend. Right, that turning point. My horizontal asymptote here on the original graph is at y equals, well, it's some number between 0 and 1. It's reasonably close to a half. So if I turn that upside down, the horizontal asymptote would now be the line y equals 2, or some number depending on what that fraction actually was. So I'll draw that in. What else can I do? I know that when the original function is increasing, the reciprocal will be decreasing, and vice versa. So when the original graph's going up, the new graph will be going down, and so on. I also know the sign's not going to change. Turn a positive number upside down, it's still going to be positive. Same with negatives. So let's put some more information in. So that being the case then, my original curve over here on the left-hand side is always positive. So when I turn it upside down, it's still going to be positive. However, any number that was originally below 1 will now go above 1. So I know it must be in this little section here. Can't go past the horizontal asymptote because the original graph didn't. So when I turn it upside down, it's still not going to go past my new horizontal asymptote. So I know it's captured in just that little rectangle there. The next section, where I've gone from y equals 1 up until my old asymptote, it was always above 1. So when I turn it upside down, it must always be below 1. And so I know it exists in this rectangle here. It does cut the horizontal asymptote, you'll notice. So the reciprocal, we would cut the horizontal asymptote as well. We know it's going to go through our x-intercept, whether or not it's a point of discontinuity is an argument we can have. But then when I go down below, I can do a similar thing. When it's below negative 1, then when I turn upside down, it'll go above negative 1. And then here for this little section before our new asymptote, when it's above negative 1, it'll go below negative 1. And I've basically done that for each section up until I got to the very end where my graph was completely below the horizontal asymptote. So I knew my new one will be completely above the horizontal asymptote. And I've still got to bend towards the asymptotes and things like that. So the last section there is probably the easiest part of the graph to draw now because it looks like it's just going to be like our traditional hyperbola in that particular section. Okay, what else? Sometimes it's handy to do the derivative. Like I'm drawing a reciprocal curve. If I differentiate one on function x, remember our reciprocal rule, minus the derivative on the function squared. Have a look at what we've got. If on the original curve its derivative was 0, so it was a stationary point, well, this fraction's still going to be 0 because I've got minus the derivative. So stationary points will still be stationary points. The y value might change because we've turned that upside down. But at that x value, we will still have stationary points. But look what else happens. On the bottom of the fraction is function x squared. So when the original function was 0, so x-intercepts, we now have 0 on the bottom of the fraction. So something's happening there. Okay. And in this case, you'll notice, oh, well, we've already sorted that bit out for this curve because we've already drawn in vertical asymptote. So just as we were expecting, oh, something's going to happen there. If it wasn't a vertical asymptote, perhaps it means we've got a vertical tangent at that point. So maybe like the end of the circle. If you were to draw a tangent at that x-intercept, you'd get a vertical tangent. All right. So my turning points, that one we've already dealt with because I'm pretending it's -1. This turning point has a y value which is a fair way above 1. So if I turn it upside down, I'm thinking, oh, well, probably quite a small fraction down there somewhere. Did we have any other turning points? I think that's it. That might be enough now to draw the graph. Woo, there we go. Ta-da! Y equals 1 on function x. So I had to bend towards my asymptotes. I kept in the regions that I'd worked out, going through my x-intercept that we worked out, bending towards the asymptote. So that was the first piece. The second piece, again, bending towards the asymptote. Right? Original graph was going to 0, so yes, this is going towards infinity. Coming down to my turning point, going up, and all the way across the end. So let's get rid of those shader bits and everything. There's the actual new curve. Now, I tried to put every sort of thing I could think of into that random curve. So there were horizontal asymptotes, there were x-intercepts, there were turning points. The sort of curves you get in the test probably only has 1 or 2 of those features. It's probably not going to have all of those things thrown in. But let's see how we go. Okay, so 8D's having a go at some of the reciprocal graphs.